If you remember before, I said that the expectation that Google had when they released Kubernetes was that it would solve all of these down-the-line problems people had with packing more work into fewer machines. But it turned out the things that were actually bothering people today were just, I can't run applications.
This is DevOps Paradox, episode number 225, The Rise of Kubernetes, from Google to Global Phenomenon. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, most everybody is well aware that I am not the Kubernetes expert, and you are.
I'm not sure about that, but I'll go with it. I'll flow.
In comparison, you're much more of an expert than I am.
Fair enough.
But today we have somebody that's on with us that has been around since before Kubernetes. I guess I could say the same thing of myself, but not in relation to Kubernetes.
I mean, if you're older than, if you're not a kid, if you're not underaged, you're older than Kubernetes.
So today we have Craig Box on today. Craig, how are you doing?
I'm very well, thank you.
Did I get your name right? People know that I also have a very hard time with especially first names.
I understand. I don't blame you. I worked with a couple of people in a job in New Zealand once where I was born. I worked with a guy named Greg and an American named Tom. And my name was Craig, his name was Greg, and Tom basically used the same sound for both of us. He'd sort of say Craig, and we'd both turn around, and we got used to it. We figured it out.
So it's actually Craig.
It depends. I'm sure it's probably different for different parts of the US. It's probably pronounced differently as well. Very few famous Craigs in the US. You've got Craig Ferguson, who was on The Late Show, and you've got Daniel Craig, and I think that's about it.
Yeah, but I still say those words, Craig, as well. So let's just chalk it up to dumb Americans.
Potato, potato.
Let's leave the vegetables out of this. They did nothing to deserve that. Or maybe they did. So you're currently at Armo, which the claim to fame for Armo at this point is Kubescape, correct?
Yes, indeed.
But before you arrived at Armo, you were at...
I was at many places, but most relevant to the Kubernetes story, I guess, is that I joined Google in 2014 when they were talking about the secret internal Project 7 thing.
Secret Internal Project 7. That's a really bad code name.
They only used the Project 7 part. I think it was just implied that it was secret and internal at that point.
Does that mean that it was 6 times less important than other projects?
There is an origin story, which, depending on how familiar you are with the iconography of Kubernetes, will make sense. You know, the Kubernetes logo is a ship's wheel.
Yep.
And it's wrapped in a polygon. Have you counted the spokes on the wheel or the number of sides on the polygon?
I didn't. If I had to make a wild guess, I would say 8, but now I suspect it's 7.
Oh no, it's symmetrical in some directions, obviously, but there are 7. If you remember, there was a company called Heptio, the heptagon, 7 sides. That is, again, another reference to 7 in the project. They're dotted through everywhere.
So you were around before Kubernetes was Kubernetes, is what I'm hearing.
I was aware of the project before it, and it's not one of those things where they have job ads that say, you must have 15 years of Kubernetes experience, and the thing launched 8 years ago, and I can't quite claim that, although I do know the people who can. But like I say, I joined Google. The very first offsite meeting I went to was in Seattle, which is where the team were putting the prototypes that would become Kubernetes together. And I heard about this project and went back to the UK where I was based thinking, I've got to start going and telling customers that they need to look into this Docker thing, but I can't tell them why for a few months.
Hey, but if you told them that, then you would have to explain later why they should now invest in transitioning.
Docker itself was obviously useful, and that's why it was adopted as the base for Kubernetes. But the ability for people to take those artifacts and cluster them and solve problems that they had was something that resonated very quickly with people. And we were honestly surprised which of the things that Kubernetes did resonated the most with people when it launched.
What were some of those items? Other than the obvious, wow, here's a new zip file format that I have to learn.
If you think about what Kubernetes was, it was an API-driven system where you could declare an intention to run code, and then it would run across multiple machines, and it would smartly or intelligently pack that work as best as it could onto those machines, so you'd be able to get a higher utilization than you would just doing it yourself. And in theory, it was the latter thing that we thought most people would go for, is that this is a way to save people money and to run more code on fewer machines. But it turns out that people just hadn't figured the front part of it out yet, the former part. They weren't able to reliably deploy things and know that they'd get things done, especially in that declarative fashion. So a lot of the early adopters of Kubernetes, they did things like just run one container per machine, and they were fine with that. It was a more reliable way to do a thing that they understood. And then later on, as they started packing their containers down and they weren't building entire distribution images, 700 meg containers like they were with VMs in the past, then eventually they started getting to some of the benefits of bin packing and getting things down smaller.
What made Kubernetes crush Mesos and Swarm and others? Because in Nomad, for example, at that time, I remember it wasn't at all clear that it will be Kubernetes, right? Now, if you fast forward a couple of years, that became abundantly clear. But in the early days, it wasn't at all, at least not to me.
I don't work at Google anymore, but I did have years of training that suggested that we're not allowed to say anything crushes anything else. That was a very much a fair playing field. You're right in saying that there were a lot of things that came out around the same time. Even the event that Kubernetes launched at, which was DockerCon in 2014, there were at least two other people who released similar tools that you probably don't remember. One of them was Spotify's internal tool Helios, and to be perfectly honest, I can't even remember what the third one was. But there were options, there were other things. You mentioned Mesos that was out there. It helps, I think, to understand some of the history of how these projects came about, which I'll go over very briefly here. There was the internal system to run clusters at Google called Borg. And when I talk about super secret internal projects, that was in large part because Borg was considered a huge trade secret. And I talked before about the cost-saving benefits to things. Borg allowed Google to run services like Gmail that they could offer to people for free. And they could do that because they were able to pack so much work into machines and run server-side compute much lower cost than the rest of the industry could. And this was a trade secret. They never talked about it. Whether or not it was because they were afraid that the Star Trek lawyers would come after them or not, we will not say. But it turned out that there were people who came and worked at Google and went to other companies and said, hey, I missed that Borg thing. I want something like that. So there were other implementations of things come about. There was one built at Facebook, which was called Tupperware, as I understand it. Mesos started off as a university project. There were some interns who'd come and did a bit of work at Google, as I understand. They went back to UC Berkeley, and some of them went on to work at Twitter, and some people there at Twitter saw this project and said, hey, we think we can solve our cluster compute project and do something that looks a bit like Borg with Mesos. And it wasn't exactly the same paradigm. It was designed primarily for batch work, but there was a sort of a Cambrian explosion of these ideas, which obviously you saw in open source when Kubernetes came about. There were other ones, Nomad you mentioned before, some of them trying to solve slightly different problems, but some of them just trying to land grab and be the one that succeeds. As to why Kubernetes succeeded, I think that having Google's pedigree behind it was massively important to start with. But then a year into it, it was almost like Google had to backtrack and say, all right, well, this is not a Google-only thing. This is something we really want everybody to adopt. And that was what led them to the formation of the Cloud Native Computing Foundation, of the CNCF, because it was something that needed to be owned in a community fashion such that people like Microsoft and Amazon would feel comfortable getting on board offering Kubernetes services. And once the other providers got in behind it, then it really hit that critical mass, which allowed it to succeed.
So you call out the reasoning of why they went to community and helped create a community. Do you think if they would have not done that, where would Kubernetes be today, and where would the other people be?
It's very hard to what-if things, but if you look at comparable technologies from the time, you can look at Google App Engine, which was this amazing, will scale to infinity and run whatever you want, as long as you write things in a very custom way that's able to work effectively running on top of Borg, on top of Google's computers. It was very well loved by the people who use it, but it wasn't very well adopted by the rest of the industry because there was no open implementation worth talking about, and because Google was effectively 3rd to 6th place in the cloud market, very nascent at the time. And so it was really the opening this up and having the adoption that, first of all, propelled Google to gain share in that space, but then also to help drive this. And so you can imagine, if you look at any kind of space, you end up with 1 or 2 winners in it over time. Things winnow down. If you look at ride sharing or hire bikes or anything, was something I was thinking about recently. You've got all these different e-scooter brands out on the street, and then eventually you get to the world where you've got Uber and Lyft, and some countries have a different version of that, but you tend to at most have 2 competitors owning a space. And I think that might have been where things ended up if not for that. It's very easy to say, all right, well, this is great, but it's proprietary, or this is not so great, but it's open, there's a community behind it. There are 3-ish operating systems that matter effectively today, if you think about Windows, Mac, and Linux. And that's because it costs a lot of money to build a system like this. There's not a lot of people who can afford to invest in those kind of things. So you really do end up with 2 to 3 at most.
I'm thinking ahead to where we're at today in 2023. We'll break out the crystal ball. Can the same be said of all of these AI players? Because in the end, I think it's just going to be OpenAI / Microsoft, Google / DeepMind. I don't see how any kind of startups are going to be able to compete against that level of consolidation and money.
AI is an interesting topic, which I'll be the first to admit that I don't know nearly enough about to give a credible answer. But what I think is that it's not so much based on the technology or the algorithms, but it's about the ability to train on very large data sets. And it may well be that only large companies have the ability to do that, but the models that are produced by them, once made available to people, are starting to run on smaller and smaller devices. There was one that was, I want to say, leaked perhaps rather than made available by Facebook, called Llama with 2 L's. And I've seen variants of that run on things as small as a smartphone now, is that you're able to do that same thing in a much smaller compute environment than you would have thought. And so it's not so much that you need large amounts of compute to run these services, but you do need large amounts of compute and data to train them. And there are other people that have environments available at that scale. Governments, for example, like it might be that the French government, just to make something up out of thin air, decides that they want to invest more in a large language model that can speak French because they are a country that are very keen on maintaining their language and culture, so that they may decide that's something. And that might be that that's something in the scope of a government to do rather than a large compute player.
Having a big player or a couple of big players or solutions from a couple of big players dominating the market does not necessarily mean that those same big players are the ones benefiting from it, right? Kubernetes is a potentially very good example, right? Biggest beneficer, or no, whatever is the word, the player that benefits most from Kubernetes is arguably the player that contributed the least, being AWS.
There are things that relate to the scale of where people are running their compute environments, and the fact that Kubernetes is not going to be the only thing that they run. For a period, hosted Kubernetes was only available on Google, and it is still, in my opinion at least, far and away the best to run on Google. But if not everything you run is Kubernetes, then that will not necessarily pull through everything to Google. It did pull a lot of things through to start with, back in the days when it was hard to run your own Kubernetes. But that almost opened up an umbrella, like we were saying before, to the other technologies. Docker Swarm came along and did a reboot and said, hey, look, we're only 2 commands. We're really easy to spin up Docker Swarm, whereas Kubernetes is very hard to set up. And that was true at the time because the GKE team had put all their effort into making it really easy to push the one button on Google to have the hosted version. And that then caused a little bit of a shift where the project went to put in some effort to make it easy to start running Kubernetes anywhere. Thus came things like kubeadm. At that point, it sort of equaled itself back out again. So I'm not really sure in terms of who you'd say that the benefactor is. People who sell tools are always going to do well in the gold rush.
When Kubernetes started, the only place you could really run it was large clusters. I'm air quoting large clusters. You needed large compute.
I will give you the benefit of the doubt there, but do remember that when Kubernetes started, there were limits, something like 5 to 10 nodes, and the thing would all just fall over.
I wouldn't say that it could run only on large scale, but it's more that at that time only large scale would benefit because it was so time demanding to actually set it up and manage and all that stuff, right? That you wouldn't want to invest. And I'm talking about very early days of kubeadm, right? You wouldn't want to invest that time in something that will run on 3 nodes unless you're really enthusiast.
By the time you've sunk the cost in learning it, then you really do want to be able to get some benefit out of using it. Running at scale was much more sensible.
That's very different today, right? Today you can just spin up managed Kubernetes cluster. Even if it's 2 nodes, you're still benefiting, assuming that you pass through that learning curve, which is also much lower today.
Yeah, so the learning curve is one thing. The ability to hire people that have already passed through that learning curve is another. There are thousands, tens of thousands of people with certifications in Kubernetes now. And so those APIs are useful to control compute even at small scale, which is where you start seeing edge devices come about. If you know how to package up something and then you want to make sure that 1 or 2 containers always run, using that same API, even if you don't need to ever go outside one machine, is useful. And that, of course, leads to other use cases, things like the service that eventually replaced App Engine at Google Cloud, which is called Cloud Run, which effectively speaks a Kubernetes-like API based on the Knative project, and then takes in a container as input. So you can squint at it and say, that's kind of like Kubernetes, and just give it things and it will run it for you and sort of fulfill that original promise, but in a way that people already know how to deal with, rather than having to learn the App Engine paradigm.
With Google Cloud Run, I had different phases. My initial phase was like, but why isn't it Kubernetes really behind the scenes? And soon afterwards is, who cares?
Yes.
Right? It's the API that I'm familiar with. For all I know, they can run it on mainframe behind the scenes. Why do I care?
I use Chrome and I use VS Code and I use Slack, and all these things effectively are just web pages running in an Electron environment in some cases. I could have a Chromebook underneath them. I could have a Mac underneath them. For a lot of people, the operating system is truly abstracted away. There are a lot of things I do that depend obviously on the underlying OS or the underlying hardware, but for a lot of the proverbial introductory users and people at schools and so on, they could be using a Chromebook or an iPad or whatever. They're still able to get the same experience, and that can be abstracted away from people who are not power users.
So going back to my flawed premise of big scale for Kubernetes initially, today, and you said it, we go out to edge to where we may only be running 1, 2 containers, just super small. And this is where we're headed into what Kubescape can help out with, because just like how compute initially began, how do we help secure things? Well, okay, used to we would run on a mainframe, then we started running on hardware, standalone hardware, then we got into virtualized machines, and now we've gotten to the point to where we're running containers, and now we're actually running containers on super small devices, i.e. Raspberry Pis. But yet, our security exposure is probably getting worse and worse as time goes along. So how do we maintain that in a sane way?
Let me ask a question here before Craig answers it. Is it getting worse and worse, or we are more and more aware of it?
The answer will be a combination of those two, is that the same is true as everything, is that the baseline is rising, that the tide is rising with the operating systems are more secure than they used to be. If you remember all of the bugs you used to get on Windows 95, 98 systems, and then eventually they were hardened with NT and XP and so on, and you get to the point where there's no one sort of going and saying, hey, Windows is grossly insecure in the way that they used to. And a lot of the technology in address space randomization and CPUs and so on that can be pulled through into operating systems, it gets to the point where the baseline is better, and so now the types of attacks are changing and a lot more social engineering. It also has changed a lot in the sense that people have found a way to make money off insecurity. People used to just cause hassle and upset people with viruses and so on. But now they have the concept of ransomware, which is largely driven by cryptocurrency and making it possible to anonymously move money around and translate it back into real currency. The kind of attacks have changed. The people involved have changed. The compute landscape has changed a little bit as well. How we're interacting with compute, we are largely now using mobile devices that talk to a backend server. There are very few heavy applications running on desktops anymore. It's very much a client-server model, and that goes back and forward every few years as to how that, whether people are running local apps or whether people are running web pages that just talk to a server. It has been a period of big change.
So this, again, going back to one of the reasons why you're here today is, talking about Kubescape, the project, and we can talk about Armo, the company, in a little bit later. What problem is Kubescape solving for people that are either running Kubernetes or packaging their application for Kubernetes?
If you remember before, I said that the expectation that Google had when they released Kubernetes was that it would solve all of these down-the-line problems people had with packing more work into fewer machines. But it turned out the things that were actually bothering people today were just, I can't run applications. And I think that the same thing is largely true with security today. There are a lot of different things out there with people talking about nation states attacking and people talking about all of these various self-modifying code that people can run malware and things. But most of the outages and things we hear about are someone deployed the wrong thing. Someone deployed something that violates the policy. Someone accidentally turned off a security feature and then their dashboard was exposed to the internet or something. So if you go through and have a look at the root cause of a lot of outages, it is things that can be codified in process, that can become part of policy. And there is a little bit of configuration change being almost more of an outage generating thing than software to some degree. So supply chain and everything, we can talk about that later on. That is definitely a big concern for people. But a lot of that is people either hacking's not the right word, people changing a dependency and needing to make sure that doesn't affect you, or people targeting explicit people, like in the SolarWinds case, where they were trying to attack, the vendor was trying to attack a thing that would run on a very specific set of machines. So ultimately, security at this point is something that people need to think about from what actually matters to them today. People are worried about, not so much worried about attacks, but they're worried about misconfigurations and things that they do wrong. And that talks a little bit to the story of how Kubescape was started, and the story relates back to Armo, the company that started it. So I'll tell that to give the context. Armo is a company that started off with people from the cybersecurity industry, came together building a project to deal with runtime security, founded a company around it. They went out and talked to a bunch of CISOs and people who are potential customers for this runtime security product. And it turns out they said, well, hey, that's great, but all our security stuff's handled by our DevOps people. You should go and speak to them. And you have a very different conversation when you're speaking to a DevOps person who tend to be administering the environment now that Kubernetes has pushed that control down to that level than you do with the security people. And they have different needs. They require things to support the Kubernetes environment. And they are perhaps a little bit earlier in their journey. They say, hey, we're not ready for runtime security stuff yet, but we're worried about how we can prove that our environment is safe and compliant. And this was a couple of years ago, around the time that the National Security Agency in the US published a set of guidance on how you should harden a Kubernetes cluster. And people were saying, hey, this document, great advice or whatever, how do I prove if my cluster is compliant or meets these recommendations? And so something that the Armo team had been working on at the time was an engine to look at policy, to do things for these DevOps people. And I'd say that the real time that Kubescape took off, it was published just before this document came out, but very soon afterwards there was a framework published in the Kubescape project where you could download it and basically validate your cluster against these guidelines. And that was the thing that everybody was just found to be amazing. It's like, here's a tool that can go out, check my cluster, see that it supports these things or doesn't, and then also get remediation advice to be told, hey, this is broken, but here's how we go and fix it. From that point on, it's really taken off in terms of the things that people need to think about in the day-to-day administration. They may configure their cluster once when they're setting it up. They will configure the deployments when they change them, when they deploy software to it. And then also they have to worry about the images that they deploy, the containers and the run side of the cluster. And so managing vulnerabilities in there, that is sort of the meat and potatoes day-to-day of Kubernetes security, is looking after those things. There are a lot of other things that we are going to get to with the project over time, but the thing that made Kubescape take off was this misconfiguration scanning and so on, and that part of the Armo platform was released, made into a CNCF project. We contributed it last year, and that's where we're starting as the baseline for building out a Kubernetes native security scanning and protection and platform tool Not so much as many of the other vendors who say, right, we do everything, we do cloud and mainframe and whatever, and we kind of do Kubernetes as a side note. But Armo and Kubescape, the goal is this is to do everything horizontally, if you will. It's to do everything for the Kubernetes platform.
I think I know the answer, but I'd like to hear your perspective. What's the difference between making something like that Kubernetes native versus using an existing tool and plugging it into Kubernetes?
It's almost the same thing if you think about VMs and step back a little bit. It's to say, if I've got a computer, I can run some software on it and see the processes that are running on that computer. If that computer is running a hypervisor and running 4 VMs, for example, then all the processes that I can see are just the 4 things that start those VMs running. I don't have visibility in that level to see what's running on that computer, even though it'll be opening network ports, it'll be running processes and so on. If I'm only looking at the hypervisor level, all I can see is there are 4 processes running and they're all running VMware or whatever. So that's where you need an agent that runs in the VM like you had when it was just a single machine, and it knows what's going on at the process level and so on inside that VM. The same thing is true with cloud and with Kubernetes. You can ask the cloud provider what's running, and it'll say, hey, I've got a certain number of machines. But to understand what's happening, you need to go a level down and ask the operating system on that machine, all right, what's running? And then if you have an operating system that's running a Kubernetes node, it might say, all right, well, I've got 12 Nginxes running. But it might be that they relate to different tenants, that they're in different namespaces, all of these things. And so you need something that's aware, that's able to connect to the API server, that's able to know the state of what's running on the nodes, to really have the context and say, all right, this is related to a certain person. This is a particular version. This one isn't connected to, it's not exposed to the internet. So it's not an immediate concern that it's running a vulnerable version. But if it were to be, then we need to escalate the concern of that and so on.
So Kubescape started out as runtime security, quickly pivoted to not so much runtime security, but hey, here's a PDF from the NSA. Let's create an app to do that.
Yeah, so Armo, the company, started off as a runtime security company, and there is still some of that floating around somewhere, which we're going to look at ways to bring back over time. But the conversations that the Armo people had at the time in talking to people was basically the DevOps people are more involved in security. They want something that runs in their CI pipeline. They are more interested in console tools, command line tools, and so on, and they're working exclusively in Kubernetes. That is the area that's a bet that we're making as a company to say Kubernetes is the platform for the next few years at least. And Kubescape was native to that. So the old Armo project, that's been sidelined for now, and we're focused our energy on Kubescape, and then Armo's commercial program is a platform that takes data that's from Kubescape and allows you to do reporting on it and analyze it over time and so on, and go deeper into things, predominantly for people who have compliance use cases and who want to be able to see the state of their environment. Perhaps, again, more the security officer wants the Armo product and the DevOps person wants to run Kubescape.
You mentioned earlier supply chain. Obviously, that's being driven now by government regulations in some way, shape, or form.
Definitely has been made popular. It's a topic of the month in large part due to the US government.
What are we supposed to do about that as the grunts at fill-in-the-blank company?
I would hope that there's not too much that people at the rank and file have to worry about. If you are providing software to someone downstream from you, then that's probably more of a concern. So you as a consumer of software need to be able to check and validate that the things that you're getting are what you expect and they are what they purport to be. And there are a lot of projects that have come about to help sign packages, to help validate signatures and so on, and then even to say, all right, well, only signed packages can run inside my cluster at certain levels. You can decide how much of your own internal stuff you want to do. Back in earlier jobs and roles, for example, like I used to build operating system packages, build Debian packages for software that we built locally. And that's a thing you could do, or you could just FTP it out to machines and run it there as well. So you can decide for the things that you run and build yourself, whether you want to go to the effort of signing it and so on. It's possibly a good practice in terms of then you can enable your cluster to say only run signed code. But for the dependencies, for the things that you pull, you definitely want to be able to validate that things are what they say that they are. And then something else that a lot of people don't think about as well is that you can have a bad actor, like the famous SolarWinds case, for example, who is able to sign some software even if it has been compromised. So a lot of what you need to do as a rank and file developer is make sure that your packaging system and the way you build software factors in dependencies. And you say, right, I'm building this version and I'm taking this version of my dependency. And I'm not necessarily going to take the latest of everything, because there can be a situation where they change and that introduces behavior that I don't expect. I'm sure your listeners will all have seen the famous XKCD cartoon where you have everything built on a tower of blocks and everything's held up by a tiny little piece that's maintained by one unpaid person anywhere in the world. But that is a reality now, is that if you think, hey, I've got 15 lines of code to print hello world to the screen, you're sitting on tens of thousands of lines of operating system and libraries and left pad and so on underneath that. And you need to be aware of that. I think there's a responsibility to be aware of that people didn't have sight into before, and they do now.
Is there an effort that you're aware of within Kubernetes project, core Kubernetes itself, to make it more secure by default, or to provide additional mechanism for third parties? Or now it's completely relying on third party?
The core of Kubernetes has made a choice to very much be a core, is to say that these are the APIs and things that we've built in from the beginning. Everything else is going to be extensions or add-ons or built by someone else. And they've provided all of the right API hooks and places to be able to do this. So if we take our example of code signing again and say, right, only signed containers need to run. The ability to do this is by way of a Kubernetes feature called admission control, which again is something that was developed through the Google systems, Borg and Omega that followed it. But the idea is to say, when you say, hey, run this thing on my cluster, it's able to run some arbitrary code and say, does it meet some requirement, yes or no? And you can have a policy engine there. You can have something like Gatekeeper or Caverno. And it might say, all right, we'll run the code that validates this image and see if it's okay to run. If it is, then let it in, and if not, then fail and give some kind of error. So the pieces that sit on top of Kubernetes, you can control that with Kubernetes API components. That isn't going to be a tick box in Kubernetes. That's something that you can enable however you want. Kubernetes itself is signing its packages and its binaries and so on, so that it can pass that muster on the next level up. And so you can make sure that when you're deploying Kubernetes, you are getting artifacts that are built and signed by the Kubernetes team.
But that goes back to what we were just talking about of bad actors. How can I trust the Kubernetes team? It's a sticky situation because at some point, trust but verify starts to fall apart.
Yeah, and I'm gonna fall back to Ken Thompson here, if necessary. Is like you are going to have to trust something at some point. And so a lot of people choose to trust their governments. A lot of people trust large enough vendors that have incentives to succeed and are not aligned in such a way that they're likely to look good if things go wrong for you. And open source projects as well. Like there are normally review standards that say any new piece of code needs to be validated by someone else. And the more important the code is, a more senior person perhaps needs to validate it. You look at things like the Heartbleed bug, where effectively you had 2 repeated lines and those lines caused it to jump over a piece of validation that shouldn't have happened. You can argue whether or not that might have been added by someone accidentally. It certainly seems like a kind of accident, but if you were to attack a software supply chain, that might be the kind of way that you do it. So you need to look at the scale of the projects you're looking at. You need to look at the maintainers, and that in some way is an area that the CNCF membership helps, is that by being a CNCF project at a particular level, you are saying that you are meeting certain requirements, such as a hierarchy of maintainers and publishing information on how maintainers are promoted and demoted when they move off the project and so on, or move to emeritus, and figuring out that there is a process behind this. You as a user have to decide if you trust the process, and in large part that's done by social validation.
So in your statement there, you effectively wiped out commercial closed source software as being trustworthy.
No, and one thing I do think is interesting is that there are a lot of commercial closed source vendors who will now make the source code available to you under an NDA effectively if you want to do that work. One of the benefits of open source is that you can assume that the community has done that for you, but I haven't reviewed the source code for everything that I run, not by any means. I don't have the ability or the time to do anything like that either. I trust that someone like Microsoft, for example, developing a closed source operating system, that they've gone through this, they've improved over time, they've demonstrated when they've had security flaws, they've patched, and that they've turned the company around when they've had harder problems to deal with. And I'm sure that vendors who do closed source stuff also are audited, and you can ask to see their audit reports, especially if you're depending on commercial software. You can check that the company meets various ISO standards and so on. There is a system the same as in place for supply chain of parts that make an aircraft, for example, that you can trust in that situation. You just need to do a little bit more work to verify it yourself.
But I don't want to do the work. I just want it handed to me on a silver platter.
That's what Victor's for. Just ask him to do it.
Isn't that why people, among many other reasons, are actually using commercial software, right? Precisely so that they don't do that, or SaaS services and so on and so forth. I mean, many enterprises will pay a company behind open source project, even if that company will not provide any additional features, just so that they have somebody behind it.
Yeah, and you've invented Red Hat in this example. Like, you can pay someone, in the case of open source, who you trust will understand the code well enough to deliver you a fix very quickly if there is a problem that's discovered.
I was sort of being serious. I'm sort of joking as well, but okay. You ended up at, well, you created Red Hat. Well, yeah, that's what happened.
Yeah, you have to think about the same risk situation. Like, if I take a plane somewhere, I went to a meeting, company week, a couple of weeks ago. In the process of flying internationally, there is so much that I can't personally understand or verify, but I trust that governments and regulations and supply chain of nuts and bolts and so on has delivered a safe experience. And in general, I look at the news reports and say, in the most part, flying is safe, and so I'm willing to take that personal risk. But there are certainly some people who would say that they weren't.
So we're talking about risk now. Kubernetes is going to be around for a few years.
It seems pretty popular.
What happens when it's not? What comes after Kubernetes?
The singularity.
Oh, okay. Good.
The patterns behind Kubernetes build on things that have existed a long time. It is still just Linux or Windows in some cases under the cover. And that's effectively like saying, well, what happens if computers aren't around or smartphones aren't around, which are, again, just small Unix computers in the most part. We trust that unless there is some major disruption on the lines of quantum computing and so on, that the things that we have in our hands today are going to be safe, that cryptography isn't going to be broken, that the online payment system isn't all going to fall over. I think that there may be iterative improvements. That's unlikely that there's going to be something else in the Kubernetes space that comes along and does better, just like there wasn't a better desktop operating system. We're still running the ones that were invented in the 1980s, but the paradigm changes, and that's when you get new softwares. You get people running phones rather than running desktop computers, and that gives a chance for new vendors to come along. Same with search, is that Google didn't displace Microsoft on the desktop, but they succeeded in a new space, which was online.
It goes back to our trust conversation we were just having.
Microsoft obviously still exists and is still supporting Windows and has a history of making sure that it's possible to run very old software compiled from many earlier versions of Windows today. They have that relationship with businesses and so on, which very much makes them a trusted player in that space. And the same will be true of open source projects, and the ability of a project to survive past the interest of the vendor that created it is something that's very important in the CNCF. Is that they're trying to build an environment where people can contribute and build something out. So worst case scenario obviously is that if a vendor stops adding things to software, in the most part, it will still continue to work. That's perhaps the difference between a SaaS company and open source. SaaS companies get purchased, and then all of a sudden their service shuts down and there's nothing you can do about it. Whereas open source software, you have that code of that version. And the worst case there is you get some people who have decided, all right, well, we own the copyright on that code, so we're going to close source the thing and do all new development privately. And there are obviously some examples of open source companies that have made that change and changed the way that they're operating. MongoDB, Elastic, you've heard of changing their licensing models, but you can still use the version of the code that was available, last version that was open source. And that is an insurance policy people keep against that risk.
How likely it is for a big open source project to actually survive without an enterprise behind it or a vendor behind it?
Linux is sort of the existence proof of this. It's really interesting to think Linux started off as a hobbyist project by a guy in his basement in Finland. And if you look at who writes Linux today, it is driver companies. It's people who make CPUs and network cards and GPUs and so on, like the people who are building complements to Linux. There's a famous essay by Joel Spolsky that came out around 2000 talking about open source, where he talks about the idea of commoditizing your complements. So if you make peanut butter, then you want bread to be available everywhere so that people want to buy peanut butter, because the two things are complementary to each other. And ultimately with software, Microsoft in the 80s, like they wanted as many people as possible to build IBM-compatible PCs, because everyone who had one of them would need to buy a copy of Windows, and they'd succeed. That's where we are with Linux today. There are so many people working on this, coordinated, of course, by the Linux Foundation, but the code is coming from Google, who use it internally, and Oracle, who use it internally, and all these other vendors and semiconductor manufacturers and network card makers and so on. Not people in their garage anymore.
Here's a probably hot take question. Are there too many projects in the CNCF?
There are a lot of projects in general, and if you think back to the discussion before about e-scooter companies, in most categories you'll end up with one or two. There have been projects created to suit certain needs, and you should never discourage someone from doing something first of all and then releasing that. Everyone wrote their own blog engine as the first thing that they did when they were learning PHP. One of them turned out to be WordPress, and all the rest of them didn't. And that doesn't take away from the reason that people did that work. And it's okay to build something just for fun. You don't need to try and build a community around it. And I think that it's reasonable to assume that it's okay to wind down a project if it doesn't meet needs anymore. And I am seeing projects in the CNCF say, all right, well, we haven't got the traction that we need. We haven't taken off, or there is another big project in this space, and we're going to join that community. So, for example, the Open Service Mesh project was started by Microsoft a few years ago, and that project now has decided to put itself forward for archival in the CNCF, and the team who are working on that have joined the Istio project. And as a member of the Istio project, that's amazing. That's exactly what we hoped would happen with the CNCF, is that we would get all of the people who are working on this space to sort of consolidate around an open project.
So it's interesting that you bring up Istio, because much like the Uber and Lyft scenario, there's Linkerd and Istio. Mm-hmm. There really isn't a third or sixth that we can talk about.
I would say that there was a Datadog survey last year, and I think, I'm not going to get the numbers right, but let's assume it was something like Istio 60-70%, Linkerd 15 to 20, and everyone else a couple of points each.
So again, is that just Google? Because Istio was, I will say, famously not open source for a while, correct?
Always open source, not a CNCF project.
Not CNCF project. Thank you. Sorry, I misspoke. So not a CNCF project, seemed reticent to actually submit themselves to CNCF, but yet that changed. Again, this is my perception of it, right? True or false, it's just my perception of it. They were late to the game to the CNCF. I'll put it that way. Why would a project that is associated with Kubernetes not want to be in the CNCF?
That is a question that you can buy me a beer one day and I'll give you the actual answer to. But what I will say is that there are largely two different types of company working on open source. You have the startups for whom the project is required to have the survival of the company. So you can say Kubescape and Armo are in that situation effectively. Buoyant, the company behind Linkerd, their success is intricately tied to that. Then you have companies who make something else. Let's talk about LinkedIn. They make software for bugging people about connecting to people they've met at a conference. And they also ended up making a piece of backend software that they needed to power the system, and that's Kafka. And it turns out that it's not the primary thing that the company does, so the people who built that went off and started a company of their own around that called Confluent, and you end up in the same kind of situation that you have a company dependent on that. You do have companies like Google who do search, and they do AI and all that kind of stuff, and they also have some open source projects, but it's not as key, obviously. It's not that. And the same is true of Linux vendors, people who make network cards and so on. It is supporting an open source project is something they do on the side. And I think that you get two very different models The CNCF is obviously largely funded by the biggest companies who are the Platinum members, and a lot of those companies are your Oracles and Googles and VMwares and Amazons and so on. And then you have the people who are innovating in this space and starting startups and so on, and they are smaller vendors out there, and hopefully they'll grow into bigger ones over time. But you do get a different engagement model with open source when you have a big company who's just got a team working on something versus a small company for whom that is the only thing the company does.
Given the size of CNCF, how likely it is for a company in that space to survive these days? I'm talking about startup, right? Without entering the foundation.
There is a lot of debate about this happening continually. We all have our own opinions on it. I will say that the SDO project survived and thrived outside of the CNCF, yet it is in the CNCF as a graduated project as we speak today.
I bet more like a small company, like, let's say Armo, right?
Mm-hmm. Well, there are different business models that you can take, and there are a lot of security vendors that aren't putting their projects in the CNCF. There are a lot of security vendors who are putting a small project that is a sort of a side to what they do in the CNCF. Armo said, all right, well, there are companies already doing that, running those business models. We're going to run the business model of we're full-on CNCF from the start. That's what we're going to do. And I think that there's opportunity in all of those spaces. But when you start a company, you look around and see what kind of competition you expect to be up against and find your niche and find a place that works for you.
So Armo is at armosec.io. That's ARMOSEC.io. Kubescape can be found right on that site. In fact, right beside Armo, there's a big drop down for Kubescape. And by the way, you all have the cutest little panda astronauts, I have to admit.
That's very kind. Make sure you grab a little plushy version of it when you come to see our booth at KubeCon next.
Only if I could go to KubeCon, but that's a different conversation for a different day. But Victor will be there. In fact, since you mentioned KubeCon, I'm assuming you will be at KubeCon Chicago.
Armo will definitely be at KubeCon Chicago. And I should point out that the Kubescape project had a kiosk of its own as a CNCF project at the last Europe KubeCon, and we'll hopefully have the same again in Chicago. But I will probably not be able to travel to that one for a family situation. So I will leave that in the hands of my colleagues.
It's just Chicago. You've had Chicago pizza before. There's no other reason to go.
I'll tell you my Chicago pizza experience to warn everybody off. Is they say, right, you've pizza's ordered, it'll be 45 minutes. Would you like some mozzarella sticks while you wait? And the correct answer to that is no, I would not. Because if you eat the mozzarella sticks, you have no appetite for the pizza at all. And the pizza is delicious, and you wish you had appetite for the pizza, but you don't because you didn't listen and you ate the mozzarella sticks.
There you go. That's good information there. Craig, anything else that you would like to say as we're closing out here?
Yeah, just thanks very much, guys, for having me. You mentioned Armo's website. Armo makes a platform which takes in Kubescape data and does processing and makes it available to people, reporting, and builds out a bunch of stuff. You can also go to Kubescape's website, kubescape.io, and you can get the open source components that run in your cluster and get a lot of value out of them too. We want to see as many people as possible getting behind this. We are, as we say, full on as the CNCF project in this space, and we would love to see people use Kubescape, tell us what things they would get benefit out of us building, and then possibly contribute to it as well.
Let's see if I can get this right. Craig, thanks for being with us.
Well done.
Craig. Thank you. Thank you.
I appreciate it, Darren. Thank you very much.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.